Next up, we will have squash vein yellowing virus with Dr. Adkins.
All right. Good morning, ladies and gentlemen, or good afternoon, good evening, or good night, depending on where you are. I'm Scott Adkins. I'm going to bring you a Florida perspective from just a little bit south of Sudeep. So I've been in Florida for almost 30 years. And when I arrived, there were no whitefly transmitted viruses in cucurbits, exactly as Rebecca has outlined for the US. The big thing everybody was worried about were what in South Florida was papaya ring spot virus, which of course is an aphid transmitted potivirus. That continues present through today. But along the way, you've heard in several different ways, unprecedented numbers of whiteflies blew up with the biotype change on cucurbits. And this is in Florida, this is elsewhere in the southeast. Following those large numbers of whiteflies came new viruses. And this is a photo of an underside of squash leaf up where Sudeep is, taken by my friend Shaker and Babu, spring of 2017, I believe, on this. So we can look at these viruses in several different ways, and I would simply list them to start with. Squash vein yellowing virus is what I will be talking with you about. Cucurbit leaf crumple virus. Sudeep just educated us on CYSDV. Bill got us on, and I think Bill's coming up next to talk about CCYV. When this started back in the early 2000s, I used to show a map and locate the viruses, but now the viruses are pretty much everywhere, with the exception of I'm not sure of, I've seen a CYV report from South Carolina. But as of April, the geographic map for our corner of the world is not terribly helpful. The chronological map, very similar to what Rebecca showed, is kind of interesting. Again, PRSV was here from 1960s onwards in the watermelon industry. Squash vein yellowing virus showed up in the fall of 2003, or it was identified in the fall of 2003. Cucurbit leaf crumple trailed about 3 years behind that, and CYSDV another year behind that in the fall of 2000. You'll see the whitefly transmitted viruses have a black hole here from the late 2010, 12, 13 up to the spring of 2016. Sudeep talked about cold weather in Georgia. We really don't have much cold weather here, but we did have a few significant freezes during that period of time. We also had a couple of monster hurricanes through our cucurbit production region, and people stopped paying attention to whiteflies and the viruses they transmit. In spring of 2016, that changed, and we got everything in gear again, and these viruses have stayed here through the present time. I might start by giving you the ending. This parallels what you've heard from all three of our speakers this morning. Symptoms are confusing or maybe not even present. Therefore, you need accurate diagnosis for what virus is present. We need to always be watching because it's a small world and pathogens continue to emerge. But particularly squash vein yellowing virus gives us an interesting opportunity to look at neighborhood or area-wide pest management. Again, I'm Scott Adkins. I'm a virologist with USDA's Agricultural Research Service at the U.S. Horticultural Research Laboratory in Fort Pierce, Florida. And I'm here to talk about squash vein yellowing virus and viral watermelon vine decline. So plant viruses are generally named for the host in which they were first found and the symptoms that were caused in that host. And so as you might guess, squash is where Susan Webb, Carly Baker, and I found this virus in Florida first time. It has very striking yellowing of the veins. In yellow squash in particular, you'll get green streaks on the fruit, which unless you're very clever with your marketing, can be economically troubling. The big problem is here in the middle in watermelon. And at or shortly before harvest, the field will collapse, leaving you with unmarketable fruit with necrosis in the rind. And this all comes from a very innocuous sort of a beginning where you'll see a flagging leaf out at the tip of a vine starts to turn yellow, starts to wilt. You see a little wilting and necrosis of the vein on this lobe of the watermelon leaf. But very rapidly, it proceeds to this, and you'll have a weak spot develop in the field where a few plants are collapsing, then a few rows of plants are collapsing, and then the whole plant collapse right about harvest time. I've been in growers' fields where I've seen this on a Friday, and on Monday it looks like this. In the early 2000s, the National Watermelon Association estimated over $60 million in losses in watermelon in Florida due to this virus. You'll notice I say viral watermelon vine decline. I say that because it looks very similar to fungal vascular wilts, and these would be things like verticillium or fusarium. We've since found a number of other fungi that will cause similar symptoms. Why you need to have diagnosis is that in this case, your first intention, your first idea would probably be a fungus. If you start applying fungicides, you're not going to get any relief because this disease is caused by a virus. Beyond the plant, the impact is on the fruit, and you'll get this necrosis in the rind, but what is most troubling is the degradation of the flesh. And you see these two fruits at the top from an SqVYV infected plant that look like they're overripe. They are the same chronological age as these two fruit at the bottom from a non-infected plant. And clearly those are more marketable than the ones at the top. To give you an overview of the biology, you've heard about different types of transmission for the previous two viruses. SqVYV is semi-persistently transmitted by the same silverleaf whitefly, sweet potato whitefly, biotype B, now meme1. It takes about a half an hour to acquire the virus. It will not keep it for very long. Within 24 hours, it will be gone. So the action is pretty fast. There is no seed transmission of SqVYV in watermelon. We've tested quite a lot of watermelon seed from infected plants. Symptoms of all of these viruses are similar, particularly in the sense that there are mixed infections with all the whitefly-transmitted viruses that are quite common, as Sudeep has indicated, again, making accurate identification essential for your management. We've developed a number of diagnostic techniques, including tissue blots and RT-PCR, moved on into ELISA and QRT-PCR. Others have picked these up with LAMP and other multiplex techniques. The most interesting thing we've looked at for epidemiological purposes is try to do this in real time without sampling by using a dog. I would show you Tanya here on a watermelon bed wearing special shoes so she doesn't poke through the plastic, and at the edge of a fallow field. In both cases, she's alerted on an infected watermelon or an infected balsam apple that could then be rogued or treated in some manner. Just an idea to keep in mind for an area-wide program. You could cover a lot of territory very easily with a dog. Where is SqVYV? In the U.S., the southeast corner is really where vine decline has been, viral vine decline has been an issue. Florida, Georgia, South Carolina, but it's also been detected in Indiana, California, Texas, Arizona, and Puerto Rico. In the Caribbean, also Guatemala, Guadeloupe, and in Central America, Guatemala. Fruit in the lower right looks very strikingly similar to what you've seen from Florida with the rind necrosis and the flesh degradation. SqVYV has also been detected in 4 or 5 countries in the Middle East. So what can we do about it? Similar to what you've heard from my colleagues earlier this morning, you can do all of the things listed here. Scheduling your timing and location of fields away from other cucurbits or whitefly sources following a significant weather event. After a freeze is good because the reservoirs for the virus and the whiteflies are down. Whenever you plant, you'll want to try to manage the whitefly as well as the vector. Resistance is coming. Shaker Calcic has identified some watermelon accessions with resistance. They are not yet commercially available. Further down the road would be preseason risk prediction models and neighborhood or area-wide management techniques. So look at insecticides for whitefly management. The bottom portion of this bed of a trial of Shaker Calcics that we did with Pam Roberts and Bill Turchek compared to the untreated, compared to the treated part at the top. Treated part, the watermelons are alive. At the untreated part with insecticide for the whitefly, the plants are dead. Similarly, on mulch color, you've heard several comments from Bill and Sudeep about that, black or white, depending on the season. Silver mulch is really good. In watermelons, it has a finite lifespan because the vines will run over the bed and you'll lose that reflection uh, that would give you the benefit. Reservoirs for the virus. Reservoir simply meaning a source of the virus. In Florida, these are cucurbit weeds. And one of those is balsam apple, Mortica charantia. You'll see one here in a bed with a watermelon. The balsam apple looks very good. The watermelon is dead. And this balsam apple has a mixed infection of SqVYV and cucurbit leaf crumple virus. Here's another wild cucurbit in Florida of smell melon, Cucumis mellodudium. You'll see a little yellowing at the oldest leaves near the crown of the plant. That's due to the triple infection with the CYSDV that Bill started us off with today. So the cucurbit weeds in the southeastern U.S. will provide reservoirs for all of these viruses. Cucurbit crop volunteers will also provide reservoirs for all of these viruses. And therefore, you really want to watch your volunteer crops. You want to rotate your fields if you're able to do that. I mentioned resistance for SqVYV. This is work identified by Shaker in trials with Pam, Bill, and me. You'll see one of his lines up here in the front that is still very much alive compared to a commercial susceptible watermelon cultivar in the back. This squash plant is our inoculum source from which whiteflies spread the virus through the field. Again, Sudeep mentioned IPM. You'll want to do all of these things to the extent that you can to manage squash vein yellowing virus and the watermelon vine decline that it causes. With that, I would acknowledge Sal, Carrie, Gavin, and Jeff, along with Reed, who have helped me over the years with the research. The groups in green up here in the upper right, we've had the unfailing support of growers, seed companies, university, and extension faculty, along with Glades Crop Care and other commercial crop scouting agencies, and regulatory folks at both the federal and state level across multiple states who have provided us unfailing support. And finally, in orange down here at the bottom, all the groups who have funded my research over the years. With that, I will thank you very much for your attention and pass the baton back to Rebecca.
All right. Thank you, Dr. Adkins.